Hi, this is Steve Barton for Solid Rock Machine Shop Incorporated. Today we're going to be doing part number 3 on our Squareness checker. We're doing the nose piece right now, and there's not going to be nothing really exciting in here. We're just going to finish this up and get it ready for a heat treat. The next stage, what we'll do is we'll cut our little notches in the side of the block here. Last week we put the radiuses on here. So what we'll do is we'll set this up, center it in the vise, tap it down, right now I'm just barely touching the top of the part. I can establish my Z. We just take a light cut. Spin the part 180 degrees. We'll take a nice light cut again. And this is the way I can establish where I'm at with the cutter in relation to the part. What I want to do is I want to make this, at the finish size, is going to be a 1/2 inch. That we want left on. Right now I got it set where I just took a small cut. I'm going to take a micrometer and I'm going to measure that. And it looks like we're at 970 thousandths. That means if I'm going to leave a 1/2 inch, we want grind stock on it, so I'll leave 510 thousandths. It means we need 460 thousandths to take off, 230 aside. Now by putting the block in the center, getting established on with our cut, so I know where the end mill is in relation with the cutter. I know I need to go 230 to my finished side over, turning the block around 180 degrees, going to the same dimension. I know I'm going to be central with the 1/2 inch is going to be central with the block because this jaw's not movable, everything's being referenced off the bat. Take about 50 thousandths at a time. I'm conventional milling right now. I'm pushing into the part, blank baffling with that. I have everything roughed out now. I use the conventional milling to cut where I'm pushing into the part. The cutter's spinning this way, and I'm going in this direction, therefore it's wanting to push. Now I'm going to do the semi-finished cut, and I'm going to climb mill. The cutter's spinning this way, I'm going to start on this side and work this way. When you climb mill, you got to be careful, because if you take too much stock off, the table's not stuck down. A lot of times the slop in the lead screw and the ball nut, there's some slop in there, and there's enough pressure on the cutter on the part that it will pull it forward the amount of your slop. And when it does that, if there's a lot of slop, they can push fast enough where the cutter cuts in deeper, wants to bite in harder, and then it will snap the end mill. You can mess up your part, break an end mill. What I'm going to do is I'm going to just take 5/1000 and reset my dig go at 0. I'm going to lightly snug my cable down. By snugging the table down a little bit, taking a light cut, I don't have to worry about there being enough gripping force of the cutter that it's going to move my part, and therefore I won't break the end mill. The advantages that you have when you climb mill is that you get a better looking finish. It's actually easier on the end mill. It cuts with less distortion. We're just exactly where we wanted to be. We're at 520 thousandths now, so that gives us 5 thousandths per side to take off yet. We're 510 thousandths, that's what we want to be. We give us 5 thousandths grind stock on both surfaces. We'll file it off, take the burrs off. Next thing we want to do is turn it upside down, and we want to remove about 3/8 of an inch off of here to make our step. We're going to use a different cutter. Touch the top to establish the Z. Wind down 100 thou. And now we're just going to touch the side here with the cutter. Again, these dimensions aren't critical. Be working close to the vise, so I just want to make sure I wasn't going to hit the jaw there. If Adam can come over and get a close-up, I step this down because I need to put a nice looking radius in there. What I do to get the radius in, I'll take an end mill that I've used that got the corners tore up a little bit, and I'll take it to the grinding wheel, and then I'll just hand grind some nice radiuses in there. And you can probably zoom up and show that. Again, this is nothing real precision, real critical. And believe it or not, you don't have to have a special green silicone wheel to grind those. That's just on a regular grinding wheel on the bench grinder, and it works. going to do right now, we're going to establish the Z. Like I say, I knew I was going to be really close to the top of the jaw, so I got to be careful. There, that worked out good. Adam, you can zoom up over here and you can see the nice radius, nice finish, fine milling. Now what we need to do is we need to drill our hole. Drill countable for a 1/4 20 socket head cap screw. And then we've got to deburr it, and then we'll be done. I'm going to find the center of the part and the Y, so we don't have much room unless I go over here to hit on the part, so we're just going to hit in the jaws themselves. And we'll take a dimension off the bottom of this for our X. Now we have the part. Bring it over to the bench grinder. Here we have one of these Scotch-Brite wheels. They're good for taking the small burrs off. Leaves a nice finish. They're not very aggressive. I don't know if you can get a close-up on just that little bit of deburring. It takes the edges off real nice. We'll do this again after it's heat treated when we grind it. We'll take all the sharp edges off that. Anyhow, that's the third part in that series. Now all we have to do is send both parts out to heat treat, and then we'll start on the grind process. Thanks for watching.